But what concerns weather, there is only one top choice, top association, namely Bricis from the Latvian TV, who has been analyzing weather trends and weather forecasts, in particular with regards to agriculture. Let us welcome Bricis onto the stage. Good morning. I'm very happy to be here. I have been working with weather for more than 20 years, with climate issues for more than 20 years, and have cooperated with many sectors, including agriculture, and the challenges that farmers face. I think this is mostly one of the most affected sectors. And before I start telling and showing data, I wanted to provide a short summary on climate change. We really speak a lot about that and speak more and more about that, but unfortunately these discussions are quite general. And when I work with farmers and with other sectors, I see that on both sides, both the meteorologists and climatologists and the sectors actually lack cooperation to achieve deep understanding and good results. Also, from the point of view of climatologists, when we speak about the future, we know that it will become warmer, the average temperature will increase, and that's quite clear. But when we look into details, there are quite many unknown factors in weather forecasts and in weather trends. Yes, we hear there'll be more extreme weather, there'll be warming and so on, but the devil hides in the detail. But what exactly will happen in Latvia in each region, in each field? There are too much uncertainty. And when we speak about future risks, they can be classified into several groups. If we speak about future changes that will result in injury or damage to us, then we can forecast that, we can allocate funds to cover these losses, maybe we can use insurance or whatever. If we know that this happens, that this will happen, but we don't know how it will happen, then such changes are very expensive and could be very devastating. But then there is a third group that we should discuss the most. And at the beginning, we did not hear about that from the minister. These are the changes that we can prepare for, that we can counter, or that we can use for our benefits, and then these risks become our benefits. And on a wider scale, on the European background, Latvia is not in the worst position what concerns risks and possibilities, because in the south of Europe there'll be many more risks that cannot be transformed into benefits, and they face higher risks than in Latvia. What concerns climate change, you can see the temperature diagram. This is something quite traditional that you always see, that the average temperature increases, and the basic points or the comparison period is 30 years from 1980s, and we see the average temperature, and we see a clear trend that the temperature is increasing, and it's not discussed anymore. During the last few years, we have recorded the highest temperatures ever. In Latvia, the temperature records have been kept for more than 100 years. This has happened since 1924. And I looked at the warmest year in Latvia ever, 2020. Here's the average temperature more than 2 degrees above the climatic norm. And we can, by looking at this year, we can come up with some trends that will apply to future climate and some will not. Actually, the average temperature in Latvia is calculated on or is achieved mostly due to warm winters. This was the winter when we almost had no snow in Latvia. The winter was extremely warm, followed by cool spring, in particular in April when there was still snow that never snowed in winter. Summer was average and autumn was warm. This is an extreme year in Latvia. So the winter was warm. I don't know what it means for farmers. It's difficult for me to tell. I assume that for some crops it's too warm. It could be dangerous, in particular if there is a lot of precipitation. But for some crops it's quite fine. And what concerns future seasons and changes in temperature, we see that winters in Latvia will become much warmer than before. And even by relying on our selective memory, I think we could still see, even in our experience, that the winters have become warmer. And this is one of the risks that we need to study. Unfortunately, it hasn't done. Black frost quite often affects the fields and crops. The Latvian University of Agriculture, though they have changed their name, last year they didn't produce any studies on black frost and its effects. I think this is one of the most serious risks in agriculture that is understudied. Also, state administration, the politicians, when they speak about climate change and the relevance of climate change, and the meteorology center, unfortunately, it has very little capacity for studies. One of the examples is the alert system, which I think is the most important result, the top of the pyramid of what meteorologists do. And by improving the alert system, or when the alert system was improved, it was mostly done by relying on the enthusiasm and motivation of the employees instead of real support from the state. And this is where we need to invest. So the winters become much warmer. That increases the risk of black frost. Previously, winters were quite stable. There was snow in December, January, February, so there were warmer periods in between, and the fields would still be protected if there is stronger stronger cold or lower temperatures. And this winter we saw that there was this warm period, and then the cold temperatures hit, and there was black frost. Then spring would be the next most affected, not so much summer and autumn. What concerns springs, they are quite interesting to look at. During the last 6 years, 5 of the 6 springs were characterized or had characteristic very late frosts, very late snow. I don't think this is the result of climate change. I think this is just an unfortunate coincidence, statistically quite unusual. But if we look at this winter, I think Scandinavian countries face a similar situation. Since October, all months have been much colder than the normal. And I think this is just a coincidence because the rest of Europe enjoyed warm winter and warm autumn. We are on the border of these two processes between the cold Scandinavian countries and the warm European countries. So we face colder weather that is replaced by warmer weather. And the last 2 weeks, I don't believe, could be described as very cold. Summers will be slightly warmer. Since 1961 to 1990, or if we compare to 1961 to 1990, the winters is more than 2 degrees warmer. And it is expected that the winters will become up to 5-6 degrees warmer. So winters become much warmer than other seasons. Also, we have had recorded some of the warmest weathers, some of the warmest summers of late. So, what concerns vegetation period, which is very important, but unfortunately it varies territorially and temporally quite a lot. Here we can see the division in parishes and civil parishes, and we have prepared models depending on data from our observation stations. We have 33 in Latvia. The rest of data are simulated. But as you see, it's quite clear. There was this Vidzema highlands with lower temperatures. In Riga, of course, the effect of the city. There we have the longest vegetation period, but of course Riga is not agricultural land, so it's not really topical for you. But there'll be changes in this regard. The vegetation period will become longer. To the right from me, we see 1961 to 1990, which is approximately 100 to 200 days. Now it's slightly longer. At the end of the century, in the entire country, it was 200 and more days. But what was the problem? I looked at Dobele as one of the towns, which is located in our agricultural area, Zemgale, with blue. You can see the vegetation period per year. And as you see from even in the 60s and 70s, the difference was the range was 100 to 230, from 160 to 230 days. Most probably the future scenarios will be as the red line tells us. And I think the future average we have already experienced. In Dobele, it is forecasted that the vegetation period will be 240 to 250 days, and during the last 10 years we have had these periods. Have we really experienced that? I think you should answer yourselves. But I look at the longest. I wanted to look at the longest vegetation period that we had in 1990 in Ventspils. I don't remember because I was too small, but my grandfather told that then we still had kolkhozs, and there was a competition between them, and the vegetation started at the end of February then, when some kolkhozs started planting potatoes to be able to harvest the first, though the results were not that great. So the vegetation period starts, but it's still problematic because the temperature drops are much higher in spring than in autumn, which is normal for the Latvian climate. Lowering of the temperature in autumn is slower than increase of the temperature in spring. The northern hemisphere, Scandinavia and the Arctic regions are still cold at that time, and we can receive Arctic air even at the beginning of May or later, and that could result in frost. And the risks increase. If we, let's say, have warm end of February, warm March, vegetation starts, and then the frost endanger it in April and May. Another problem is the solar radiation, because we cannot use longer and warmer autumns. We just don't have snow. We just don't have a sun, because there is a lot of clouds. Yes, the vegetation period can be longer, but if there is no sun, we cannot really use that. In September and in May, the average temperature is quite similar, but if we look at the solar radiation, the numbers are not even that important. These are watts per square meter, and I don't really understand what it means, even myself. But the difference between May, it's 200 to 240 in May, but in September it's twice less, just 100. So it means twice less light. In spring, the extension of the vegetation period would be much more favorable, profitable, because there is light. But at the same time, there are higher risks because there is the risk of frost and cold weather. Many of these risks cannot be really forecasted. These are risks related to the weather changes, and these can be estimated only when we improve our forecasting possibilities. We cannot really fight the fact that on May we will have snow. We cannot do much about that at the moment. But if we knew in February that this will happen, then we can do something. But unless we improve our forecasting ability, which I don't foresee in the nearest future, this will remain a huge risk. The next aspect is precipitation, and unlike temperature, the current changes and future forecasts are quite unclear. It is expected that the precipitation levels will increase in Latvia, but during the last 100 years the trend is not that visible. 30s to 60s were drier, now it's more humid, but then during the last 2 years, I think you remember them quite well. This is starting from 2018, when we had very dry and hot summers. If we look at seasons, we can see that in winter the precipitation quite increased quite reliably. And this is logical because there is more humidity, more clouds, and so on. But when in summer the temperature increases, the physics behind that is different, because in summer the precipitation in nature is different. We can see some minor trends. Let's say that maybe in July, in August, like the next month, we will have spare humidity in the air, and it will have to rain somewhere. In winter, this precipitation would be spread over the entire Latvia. But in Latvia, these rain areas or rain bands or rain territories will be quite limited what concerns the territorial scope. And then we can have, let's say, heavy rains just in one area of Latvia and no rain in other areas of Latvia. The problem is that what concerns precipitation, the forecasts are not clear at all. The same applies to wind, but wind maybe is not so important for farmers, mostly.
One more thing that I wanted to talk about it, and I have spoken about, but I want it to be spoken even more. I am not entirely clear whether it is a solvable issue or not, namely irrigation systems of groundwaters. But many of you probably have seen in Spain, Portugal, that not only grape yards are watered, but also many hundreds of hectares of cereal. And if it's done in Spain, in Portugal, then why can't it be done in Latvia? This map could be a solution. We can see that groundwater in Latvia start at the depth of 1 meter. You understand that it is not valid when there is a drought, but we have lots of water, lots more than in Spain, Portugal, or Italy. And during drought period that we experienced last year, April, May, June, if we had this irrigation system, then we could turn losses into profits, into big yields, because this drought comes together with hot weather, and that results in very good yield. Different from Europe, this might not work in the future with a problem to be solved, because the weather temperatures in southern Europe will be too high, will be unacceptable. If in Latvia we are talking about 30-35 degrees centigrade, the future scenario actually foresees 40 degrees in Latvia in some years. Rail Baltic is also constructed to endure 40 degrees, for all the technologies to endure. So I hope or I believe that in 10 or 20 years we will see that weather. But in Europe we are speaking about 50 degrees centigrade, where for many plants irrigation is not a remedy. It can be done. It is expensive. I don't know how much it might cost, but if we invest several million in irrigation and we receive in the next 3 seasons extra high yields, that would, I think, be profitable. I, as a non-professional, see it as a solution. Hail and storms is one of the things that have been foreseen in greater numbers in Latvia. You can understand that from basic physics, higher convection, which will result in bigger and more hail and storms. This is a picture from the 7th of August last year that we remember very well, and I believe that those similar conditions will repeat. We cannot do anything against hail. We could do something if we were warned on a timely basis, but it is very unlikely to be true, namely to inform respective farmers of the hail areas to hit. But the circumstances that created this hail will continue, will reproduce. This is the situation on the 7th of August. From hot and humid masses were brought in from the south. There have been years when it was hotter than this summer. For example, 2014, where the record of 37 degrees were registered. But also heat can be registered by the thickness of this hemisphere. But before the 7th of August, minimum temperature during the night, namely how much the temperature cooled down, was the following. In Salkrasti, the temperature at night reached 24.6 degrees. When the sun came up, the heat increased, but humidity did not increase. If the air is dry, then it heats and also cools down very quickly. But what happened from the west, new masses of cool air came in. One suggestion for you, if you hear warnings that there might be thunderstorms with hail, there can be times when these forecasts indeed could be true very locally and may be subject to very small areas. But if the warnings are from the very morning and on large scale for big hail, huge wind is necessary there where severe winds, and with severe winds the processes in clouds took place. The hail pieces were moving or circling up and down in the clouds, thus growing in size. And finally, it was so big as it was no longer floating in the air and came down. The amount of hail, as well as the region, its hit was promoted by those thunderstorms and clouds. If it were the usual hemisphere reaching Latvia horizontally, the same hemisphere did indeed moved horizontally, but thunderstorm hit Latvia vertically, increasing the amount of thunder. This might be the future reality as forecasted, but it can be difficult to price it into our future. There will be years in the future when we will have no hail in summer, and there will be years when hails will be frequent and in big territories. And last year, we could not even count all the places on big scale hail. Big scale is considered to be 2.5 centimeters, and there were very many areas where such big hail pieces were prominent. So my main message to you is this is a wonderful picture. Let us not consider all future risks as threats, but for some risks, let us find a common ground between meteorologists, farmers, as well as public institutions. Let us invest in some places where we can stand against nature. Then the future might be better, because Latvia, on the background of Europe, we can indeed gain more than lose in agriculture. Thank you. Thank you, Toms. Maybe there are some questions for Toms. If you have questions, although I like farming, I am not a farmer. I cannot ask the question that you have. This is your opportunity to ask Mr. Bricis something. We should wait for a microphone for everyone to hear your question. Hello? Very often at the beginning of the week, rain is promised, but as at the beginning of the week, rain is forecasted, but during the week, the percentage of the forecast falls, and it was not just one event. There have been whole seasons. How do you elaborate this module? And maybe if you don't know that there won't be rain, don't promise the rain. The problem is understandable. The main thing, especially if we talk about sites where you are looking, and the module that the site is using, there are several modules that does not contain enough pixels for you to actually understand the territory of the rain to touch upon. Similar to summer and winter rains, the module sees that there will be excess moisture, but the module cannot calculate where it will drop. It is disseminated throughout the territory, and as the time approaches, you can calculate more precisely. As I said, it, for example, hits Rundala but does not touch upon Skrunda. Unfortunately, it is our reality and non-performance of technologies. It cannot be solved in the nearest future, but the progress is there. This ability to model in greater detail in longer term periods has developed, but not this summer. I cannot promise you that this will be very precise this summer. Some other questions? There will be two more. 33 meteor stations. Is it enough for Latvia? But maybe farmers can have meteor stations, more than 300 throughout the country, or farmers do have the meteor stations. Can you use these data? No. 33 stations are too little, but unfortunately at the moment the meteorological center will increase the number by 10 stations, but the problem is that indeed the measurements have to be in these same circumstances, namely 2 meters above ground, not to be shielded from sides. Agricultures have their own stations, road builders have their stations. They can be placed together in a network, but not to forecast weather. Although during the last years we use satellite data more than data from meteor stations. Thus, the main problem, and the next person is going to talk about meteor stations, are microclimate measurements for farmers who have these meteor stations next to their fields. Do get warned that, let us say, frost locally is approaching, and that this frost is going to touch upon your field. And if you have your own local station, you can benefit from that. Unfortunately, it cannot be placed all together. We had an example from Spain that they have gathered non-professional data from meteor stations, and there was a problem that the highest temperature, 30.7 degrees, were counted. But unfortunately, the measurement was not precise. It was shielded by some obstacles that generated this excess heat. Thank you very much for your very interesting data, but you said that discrepancies from norm. What is a discrepancy? What would say that, who is to say that this is the norm? Norms are different and they change. UN, World Meteor Organization, has foreseen that norm is the average indicator from the last 30 years. You can take any parameter and calculate the average by the last 30 years with the thought that the society living at the moment here is used to these circumstances. Of course, we can also take into account reoccurrence, how often one or another thing occurred. Also, in my presentation, I did not mention that those threshold periods are different. Sometimes it's not important. For example, whether the average temperature, I had 81 until 21. At the moment, we are looking at the data 90s, 21. It does not matter which average you are taking. Sometimes it is very important, but the desired effect can be measured taking into account different periods and different thresholds.